Okay, so this lecture is going to cover the thyroid gland. The thyroid gland secretes two different hormones. We have the thyroid hormone and we have calcitonin. I'm going to talk about the thyroid hormone first, but I do want to talk a little bit about the thyroid gland and that it's unique and that it can store huge amounts of hormone, and some of the hormone can even be stored extracellularly. So there's tons of the thyroid hormone um, in the thyroid gland and in the surrounding tissue space. So the thyroid hormone is actually two hormones in one. So when we look at this, I have triiodothyronine or T3 and thyroxine or T4. So the thyroid hormone can be either one of these. The major hormone that's secreted is actually going to be your T4, but your T3 can be formed at target tissues by converting T4 into T3. So basically, predominantly we have T4 secreted, and then if we want to, we can convert it to T3. What's the big difference? The big difference between T4 and T3 is that T3 can bind much tighter to the receptors, and this tighter binding allows it to be 10 times more active than T4, so it's a lot stronger. Your textbook goes into a bunch of steps in how the thyroid hormones are synthesized. I'm not worried. Please don't go in and take the time to learn those details. I really just want you to have the big picture of the endocrine system, the glands, and the functions of the hormones. So again, don't worry about the steps in thyroid hormone synthesis. So I'm going to talk about the functions of these collectively because they're pretty much the same, other than, like I told you, 10 T3 is 10 times more active and binds tighter to the receptors, but ultimately their goal is the same. And one of the goals is going to be to increase the basal metabolic rate of whatever tissue they're binding to. And if we increase the metabolic rate of the tissue, we're indirectly also going to produce some heat because that's a byproduct of metabolism. So we increase body heat production. Because we're increasing body heat production, we say that the thyroid hormone has a calorogenic effect. Okay, other things that the thyroid hormones can do are things like regulate tissue growth and development. So the thyroid hormones are absolutely critical for if we're talking about nervous tissue, muscular tissue, or even skeletal tissue. In order for them to be correctly grow and to correctly develop, we have to have the thyroid hormone. Another thing that they do is they increase the number of adrenergic receptors on blood vessels. And in doing so, they can help maintain your blood pressure. Other things that they do, they can go in and promote um, the tone of your gastrointestinal tract as well as their secretion. So they can increase secretion of digestive juices. And what this is going to help with is metabolizing our macromolecules. So for intaking things like lipids, carbohydrates, or proteins. And yet another thing that the thyroid hormone can do is help with keeping our skin hydrated and secretory activity, again, related to our skin. There are probably 20 other functions of the thyroid hormone. These are the ones that I'm going to hold you accountable for on the exam itself. Okay, so let's talk a little bit about what is going to stimulate the release of the thyroid hormone from the thyroid gland. One is going to be, well, if we have low thyroid hormone levels, that's going to stimulate the release of the thyroid stimulating hormone, so that we can get more thyroid hormone released from the thyroid gland. Another thing to think about that can cause this, and only really it occurs in babies or infants, that babies or infants that are cold, they're actually going to increase their thyroid releasing hormone release, which is going to increase the thyroid stimulating hormone release, which is going to ultimately increase the thyroid hormone release so that we can get an increase in our body heat production. And again, this only really occurs in infants, and again in response to them being in like really cold weather. So what's going to inhibit the release is going to be if we have high levels of the thyroid hormone. And what are they going to inhibit? Not the thyroid gland itself. They're going to inhibit release of the thyroid stimulating hormone. There's other things that can inhibit the release, like glucocorticoids, iodine, the growth hormone inhibiting factor. Don't worry about those. Again, just focus on kind of what I give you here, or else you're going to get overwhelmed. So let's talk a little bit about hypo and hypersecretion of the thyroid hormone. So if we're talking about hyposecretion, we can get something called myxemia, in which we can produce something called a goiter. And basically, this is the result of not getting enough iodine in your diet. So this actually used to be a huge problem where this was endemic in a lot of countries. And how did we overcome it? Because it's due to the lack of iodine. We added iodine into something that we intake in our diet every day. So salt. So now you probably primarily buy iodized salt. What happens if we have hyposecretion of the thyroid gland is that we get a really, really, really enlarged thyroid gland, seen on your neck area, and it's huge. If we have hypersecretion, we can get something called Graves' disease. And these might sound familiar because I mentioned them previously before. So Graves' disease, basically, if you have Graves' disease, you produce all these abnormal antibodies, and these abnormal antibodies look a lot like the thyroid stimulating hormone. So they basically can mimic it, and they're going to come in and they're going to cause the thyroid hormone to be released continuously, so that we get these hypersecretion of the hormone itself. So why do these look familiar to you? Because I wrote these down for hypo and hypersecretion of the thyroid stimulating hormone. So the effects of either one of these has the same outcome, basically. Okay, let's move on to the other hormone, which is calcitonin, that can be released from our thyroid gland. And calcitonin, your textbook states that it really doesn't have a function unless it's administered at like pharmacological doses, so extremely high doses. However, I still want you to learn it in this manner because it's important. So how would it be released? It would be released in response to high blood calcium levels. So would stimulate its release. Because the function of calcitonin, when it's administered at high doses, is that if we have high blood calcium, calcitonin can come in and stimulate osteoblast activity. And if you remember from the skeletal section lecture when we went in A&P1 and talked about all the different cells found within osseous tissue, osteoblasts can go in and build bone. And when they build bone, they add calcium to the bones. So if we have high blood calcium levels, we're going to secrete calcitonin so we can stimulate osteoblasts, so we can take that excess calcium and deposit it into our bones because our bones act as a calcium storage bank. So we can deposit calcium when we need to, when our blood levels get too high, and we can withdraw it from our bones in the event that our blood calcium levels get too low. So I just want to point out right now that this works as an antagonist to the parathyroid hormone, which we're going to talk about in another lecture. To parathyroid hormone. So if it's an antagonist to the parathyroid hormone, then the parathyroid hormone is going to be activated in response to low blood calcium levels. Anyways, you can make those connections later. So just as a review, the thyroid gland releases two hormones, the thyroid hormone and calcitonin. The thyroid hormone is really basically two hormones in one. Thyroxine is the predominant hormone released. If it reaches a tissue, it can convert into T3, and T3 can bind tighter and is 10 times more active. These are the functions, basically. The predominant function is to increase metabolic weight, which is going to inadvertently increase our body heat production. And then that's it there. And calcitonin, again, understand the function if we did have really high blood calcium levels and we were to give calcitonin at high doses, what it would be. And that's it for this lecture.